Hey guys, this is Miss Dupe, and today we are going to talk about our second exponent rule, which is the quotient rule. So this rule says that to divide powers of the same base, you subtract their exponents. So while you're taking notes, you need to make sure that you pause and write this whole first part down, and then we are going to start on our our first example. Our first example is going to be 9 to the 7th power over 9 to the 4th. Now, most quotient rule problems are going to be the division that looks kind of like a fraction. So in this example, we have the base 9 and base 9, and just like in our product rule, the goal is to combine those two same bases into one base. So we're going to have one base 9, and then what we are doing is we are going to subtract the exponent from the numerator, which is 7, minus the exponent from the denominator, which is 4. So we have 9 to the 7 minus 4, which is 9 to the 3rd power. Our second example, we're just going to stick with one base again, so we are going to do 4 to the 10th over 4 to the 5th power. So once again, these have like bases, they're both 4, so we're going to combine those two base 4s into one base 4, and then we are going to subtract the exponents. So the top exponent, which is 10, minus the bottom exponent, which is 5, and our final answer is 4 to the 5th power, because 10 minus 5 is 5. Now we are going to go to a problem that has a variable base. This problem is d to the 4th power over, or divided by, d to the 2nd power. So our base that is the same is base d. We are going to subtract the top exponent 4 minus the bottom exponent 2. And our answer ends up being d to the 4 minus 2, which is 2. Our last example that we are going to do with just one base is e to the 6th divided by e to the 1st. Just like with product rule, there are many different ways that you can express and show division. We have kind of two different ways we can show division. We can either write it like a big fraction, or we can actually use the divided by sign. So here we're using the divided by sign. Our like base is e, and we are going to subtract the first exponent, which is 6, minus the second exponent, which is 1. So our answer will be e to the 6 minus 1, which is 5. Now we are going to go to some examples where we have to deal with coefficients, just like we did with product rule. So when we were doing product rule, every time we had a coefficient, we treated them with the same operation that we normally would. The only thing that has a special rule is the exponents. That's why these are called our exponent rules. So I am going to clear this page so that I have room for the next one. I think we were on problem 6. This one is negative 12x to the 4th divided by 3x squared. So in both of these problems in this one problem, both of our coefficients are negative 12 and 3. So the first thing we want to do, similar to product rule, is take care of those coefficients by doing the correct operation that we're supposed to be doing, which is division. So in your calculator, you need to do negative 12 divided by 3, which ends up being a coefficient of negative 4. Then our base is x. So we're going to combine both of those bases into 1x. And then we're going to go ahead and just subtract those exponents in one fell swoop. So we're doing 4 minus 2, which gives us a 2. So our final answer is negative 4x squared. So before we get on to anything that is super challenging, we're going to do one more just like that. 6b to the 7th divided by 2b to the 6th power. First thing we want to do is take care of those coefficients. So we are going to divide them like we're supposed to. 6 divided by 2 is 3. Then we're going to take care of our bases. So both of our bases are b, so we're allowed to use our exponents rules to combine them into 1. And then we're going to subtract our exponents, 7 minus 6, which is an exponent of 1. But remember, we could leave that as an invisible 1, so you could either have 3b to the first, or you could just have 3b, and either would be acceptable. Now we're going to get to some more difficult ones where we have multiple different bases that we need to work with. A to the 4th, C to the 6th, ooh, that was rough, divided by a squared c. So the first thing I look at in this problem are our bases, and we want to look at them in alphabetical order. So A is our first letter of the alphabet. We want to take care of all the base A's. We're going to try and combine those base A's into one base A by subtracting those exponents and using the quotient rule. So we're going to do 4 minus 2, which is a squared. Then we're going to look at our base C's. We have a base C to the 6th and regular C. Remember, the regular C has an invisible exponent of 1. We're going to combine those bases together and subtract our exponents, 6 minus 1, which is 5. Our final answer is a squared C to the 5th. So our next problem you'll want to write down here is number 9, which is negative 2 to the 9th power times negative 3 to the 7th times negative 4 to the 3rd divided by negative 2 to the 5th times negative 3 to the 5th times 4 to the 1st. So you might be wondering why we have both parentheses around our bases and times, and that's because sometimes we put parentheses around negative numbers just to group the negative and the number together, just to show that those two things go together and it's not subtraction. So the first thing we want to do is kind of look at our like bases. Our first like bases are negative 2 and negative 2. Negative 2 is the base. We also have negative 3 and negative 3. Negative 3 is the base together, and then 4 and 4. So starting from left to right, we are going to use our quotient rule to make each of these bases combined into 1. So first we have base negative 2. We're going to subtract the exponent 9 minus 5, which is negative 2 to the 4th. Now it's still going to be times our next base, which is negative 3. So base negative 3, we will combine into 1 by subtracting 7 minus 5, which is 2. And then our last base is base 4. And we are going to subtract our exponents, 3 minus 1. So that is it for our quotient rule. Let us know if you have any questions. If you need to rewatch the video, do that, and make sure you have your notes.